Good day, and welcome to our webinar on capitalizing on the promise of IoT, how to start your connected journey, brought to you by CFE Media and Technology and sponsored by PTC. Today, we'll be joined by Chris McDonald, Global Lead Analytics Center of Excellence, and Ken Rawlings, Vice President, Smart Connected Products at PTC. I'm Kevin Parker, a Senior Contributing Editor with CFE Media. In today's webinar, we'll review the management concepts, technology infrastructures, and data science you need to be familiar with to get started right away with IoT and the analytics applications that feed on newly liberated data. Stay tuned for what's sure to be an interesting, informative presentation and discussion. To get the best results from the webcast platform, please make note of the following as you participate in today's event. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right-hand corner of your screen to bring up a list of system checks to make. If you are experiencing issues with your slides or audio, please refresh the browser or click the Refresh Media button directly under the presenter's headshot. If you do need a technician, type a message into the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions area. During the presentation, you can also use the Ask a Question box to type questions for the live Q&A session at the end. You may ask questions at any time during the presentation. We'll get to as many as time allows. To download the presentation slides and certificate of completion, use the Event Resources box on the left-hand side of your screen. You can download the presentation and certificate of completion until the conclusion of the webcast. The line will break when the webcast signs off. This webcast is being recorded, including the Q&A session. We'll send you an email within a week with the direct link to the webcast archive. Now we will hear from the sponsor of today's webcast, PTC. At the conclusion of the video, you may experience a few seconds of silence to compensate for varied internet speeds. Please stay tuned for today's presentation.
IoT-driven innovation empowers industrial enterprise to solve the new, complex challenges of a changing global marketplace. Executed well, the right solution can turn the promise of industrial IoT into a powerful reality. No matter what stage of the IoT journey, there are opportunities and questions. How do you jumpstart that innovation engine? Establish connected operations that yield high return. Extract data insights for users at every touch point. And how do you optimize these IoT-enabled insights to gain competitive advantage? PTC's ThingWorks brings together the functionality, flexibility, and scalability you need to meet the pace and demands of the ever-changing digital world.
Welcome back. I'm now happy to produce today's presenters, Ken Rawlings and Chris McDonald. Ken Rawlings is Vice President, Smart Connected Products at PTC and responsible for the company's strategy, delivering ThingWorks industrial innovation solutions for product manufacturers. Ken's focus is on helping companies realize the benefits of digital transformation, supported by IoT and other technologies from PTC and Microsoft. Chris McDonald is global lead at PTC's Analytics Center of Excellence. Chris joined PTC through the acquisition of ColdLight in 2015. Through his work at companies that include Xerox, SAP, Oracle, ColdLight, and PTC, Chris helps companies harness the value of data-driven innovation. Today, Chris leads the Global Analytics Center of Excellence, a team of technical business developers, field engineers, data engineers, and data scientists dedicated to ensuring customer success with analytics. Ken and Chris, welcome to today's webinar. Gentlemen, the floor is yours.
Thank you, Kevin. Good afternoon. This is Ken Rawlings, VP of Smart Connected Products, and I'll start by talking about really PTC's mission. And our mission is to reinvent the way industrial companies design, manufacture, operate, sell, and service things with the convergence of the physical and digital worlds. And what we do is we provide technology that helps industrial companies take that journey of digital transformation through the convergence of physical and digital. The progression you see here has been described in the Harvard Business Review articles co-written by Professor Michael Porter and our CEO, Jim Heppelmann. They describe how companies are moving from standalone products to smart connected products, and technical advances are allowing the interconnection of those smart connected products into even more complete product systems. And when those systems can be further integrated, consider how a system of systems can add to productivity, reduce costs, and drive business value. This is the promise of the industrial Internet of Things. There are major market trends driving this industrial disruption. And to start, we must really understand why industrial companies are investing billions of dollars in digital transformation efforts. In our research and conversations with customers and partners, we've confirmed that there are three macro trends that are disrupting industrial companies. And these are the challenges that we find most industrial companies are facing today. First, worker and talent shortage. The aging workforce are impacting manufacturers globally, and it's harder to find the right skills to do the right jobs within the manufacturing sector. In addition, constant cost pressures for industrial companies are increasing the competition, and new entrants are moving into the industrial space, causing additional disruption. That digital disruption is coming from every direction. It's coming from new entrants, and it's also coming from some companies that have chosen to pursue digital strategies in advance of the digital transformation. These trends are echoed by our analyst firms, and we see additional major trends that are disrupting and are critical to business futures. Forrester notes that IoT strategy requires rethinking your business processes in general, and it's not simply implementing technology for technology's sake. IDC research shows that 40% of the top 100 discrete manufacturing companies will pursue product-as-a-service strategies, which are even more workable with connected product portfolios enabled by IoT. And VDC surveys indicate over half of the respondents believe that IoT is critical to their future success. In addition, Aberdeen has uncovered that 84% of products that come from digital model-based engineering processes hit their launch KPIs. And overall, McKinsey summarizes the digital thread connecting all the critical data from the manufacturer's value is real, and it's here. So the opportunity for industrial companies in transforming products, services, operations, and workers is clear. And we deliver that across the spectrum of products, workers, and operations through, first, product and service differentiation. For example, providing product design innovation from generative new services from IoT enabling business models, or the ability to get to market faster through product and service innovation. We're transforming operational effectiveness by providing the digital thread across the enterprise, allowing cost reduction from scrap and energy usage, and enabling quality and compliance. And in terms of workforce productivity, we're providing augmented reality-enabled work instructions and guidance to improve productivity and ensure worker safety and compliance. We have numerous customers that have already achieved these business outcomes with PTC, and today we'll take you through some examples and show you how that transformation is real and is happening in the market. First, we'll talk about how the expectations around service are rapidly transforming, and it's really driven by smart connected products. More and more manufacturers are expecting services to provide increased revenue and profitability, And your customers are demanding outcomes, not products. IDC reports that manufacturers want to capture 30% of revenue from services, and we have some additional surveys from our sales force that show that 74% of manufacturing executives identified service as a significant driver of future revenues. There are numerous challenges in moving to product as a service, and we have the technology to help you provide that guidance. Some of those challenges are driven by reactive models and high-cost on-site service channels that constrain how you can deliver service to your customers. We find that technicians and customers struggle to identify the correct technical information and parts at the point of service. We see that high service parts inventories and logistics cost challenges drive challenges with availability targets. And the aging workforce limits the ability to scale your services. All of these can be delivered through PTC technology, and we have solutions to these business challenges. So let's take you through some of those examples around product and service differentiation. First, let's talk about Colfax. Colfax is a leading diversified industrial technology company that provides products and services to commercial and government organizations across a wide variety of industries. Two of their primary business platforms are Howden, a manufacturer of precision air and gas handling equipment, and ESAB, a producer of welder and cutting equipment and consumables. Colfax is leveraging PTC technology in conjunction with Azure IoT to deliver cutting-edge digital transformation solutions, which we'll talk about in more detail in a subsequent slide. Next is Parata. Parata can predict, identify, assess, and remedy issues in the performance of its products with real-time insights. What Parata does is provide pharmacy automation equipment. Think of it as robots that drive the dispensing of key deliverables within a pharmacy. And Parata now can route real-time alerts into the sales force and into their market by providing customers with a new level of support that has not been available to them previously. They're leveraging IoT and remote connectivity capabilities from ThingWorx to become more proactive in customer service, and they've experienced over a 90% reduction in on-site software updates for their IoT-enabled product lines. And in addition, they've achieved a success rate of greater than 80% in remote support resolution through leveraging IoT. Next is Trane. Trane is an industry leader in heating, ventilation, and air conditioning services, and they rely on service lifecycle management solutions from PTC and the power of smart connected products and their service-centric approach to taking care of customers. They can anticipate and prevent break-fix problems by receiving predictive data and turn it into actionable information before failures occur. This not only provides product uptime and performance, but also increases the value that the intelligent services can provide to their customers' business performance. And next, I'm going to turn it over to Chris for some additional examples.
Thanks, Ken. So Ken discussed a lot of these companies are looking at outcomes in their service as they make their products more smart connected. But a key part of smart connected products are often as critical products within operations to drive efficiencies and best practices in their actual processes and operations. So Woodward is one of the oldest and largest independent designer, manufacturer, and service providers of control systems and control system components for the aerospace and industrial markets. A frequent issue that Woodward faced was any time a process error occurred and the PLM or ERP systems became out of sync, employees would have to spend valuable time working to resync databases across the disparate systems and thus the organization, greatly impacting productivity. Built upon installations of PTC's Creo and Windchill technologies, Woodward leveraged ThingWorx as a foundational technology for their manufacturing solutions, providing standard work and visual management in the operations environment, completely integrated with their automated manufacturing equipment, allowing for seamless communication between machines. Woodward is also utilizing the solution for employee training and certification tracking to ensure all members are certified before allowing operations to be completed. The automated data capabilities within the ThingWorx solution have given employees access to all information needed, including work instructions and inspection requirements tailored to their unique business unit or geography. Since implementing the ThingWorx solution in Kepware, HeroTech has gained increased visibility into the processes of its CNC shop and deeper insight into operations. The company realized early on that having access to CNC machine uptime data significantly impacted the shop's scheduling process, which was previously set on conjecture and after-the-fact analysis. Manufacturing leadership can now leverage the real-time data from the shop floor and tie it to the scheduling ERP system, optimizing the scheduling of parts to CNC modules. This process also provides greater insight into the asset and resource allocation by automatically formulating smarter questions about the current needs and priorities and determining the most effective course of action. Because of this, HeroTech has improved productivity across the shop and increased its return on investment. Elekta is a Swedish manufacturer of medical technologies for treating cancer and brain disorders. They have assets in operation in over 6,000 medical facilities and 3,800 employees worldwide, with over a quarter of those employees in the service organization. Elekta has been on the forefront of incorporating emergent technologies into their business so they can better serve their customers and patients. Most recently, Kingham has led a commitment to leverage IoT and smart connected products to deliver even more value to their customers and patients. Elekta is seeing an increase in the number of open service cases resolved remotely, improved service response times, and the new products and services upsell opportunities are being created based on the data field technicians gather on site. Before I hand it over to Ken, I just wanted to remind the audience that all of these use cases that Ken and I are talking to can be found on PTC's website. We have a dedicated section to use cases, so all of these use cases and many more can be found in greater detail there. I'll hand it over to Ken.
Thanks, Chris. Next, I'll go a little deeper into the Colfax use case. Colfax is accelerating their digital transformation across the product divisions we discussed earlier, Howden and ESAB, and they're leveraging technology from PTC and from Microsoft to make this real. They're incorporating ThingWorx and Microsoft Azure IoT into their products, and they've enabled new visibility into their manufacturing equipment data, transforming how they service and support their products. They're leveraging the flexibility of the ThingWorx platform and continuing to expand into augmented reality to deliver more value of products and service differentiation with their product lines. They've chosen a default reference architecture based on a combination of PTC and Microsoft technology that is enabling them to deliver IoT applications across those multiple product lines, and in addition, providing cutting-edge augmented reality solutions, leveraging both the Vuforia technology from PTC as well as the Microsoft HoloLens. And as Chris echoed, there's specific examples on our website to go into more detail in terms of the value that Colfax is getting across their Howden and ESAB divisions. And next, I'll turn it back to Chris.
TSM designs, develops, and manufactures material handling systems for the plastics industry. Their main challenge is the lack of visibility of actual material costs, that the plastics industry did not always have a good visibility of the actual material cost. By using ThingWorx, scalable web-based solution, they were able to streamline processes and gain access to the data that enables their customers to implement lean manufacturing programs. Plus, ThingWorx Industrial Connectivity allows 150 connection protocols for fast integration into almost any factory communications environment. Ken?
We went through a few examples today, but we have over 1,300 customers across a spectrum of manufacturing industries that are leveraging PTC technology to drive industrial innovation and take advantage of digital transformation initiatives. Whether it's in the industrial sector, commercial equipment, life sciences, medical devices. We have numerous customer examples where they're delivering value. And what we'll start today as we talk about these in more detail is how you can get immediate value leveraging a combination of transformative approaches to drive innovation within products and service, as well as how you can leverage analytics to drive that value. What we're finding is the digital transformation really impacts the entire enterprise across your entire value chain, across all functions of your business, and as mentioned in the previous slide, across multiple industries. So we see customers starting with how they can transform their service and drive the value that we just described around upsetting not only the market that they're in, but also changing how they can drive additional revenue on top of their product revenue through value-added services. Next, we see, based on the visualization of that smart connected product data, customers taking advantage across their customer operations through, in addition, leveraging upsell opportunities through sales, transforming their manufacturing operations by having smart connected product data, and finally using data-driven design techniques to drive the next generation of engineering designs as they iterate through their products. So let's go a little deeper into service. Service leaders are really tasked with driving more revenue and profitability. And there are unmet service outcomes that provide challenges when you're a product OEM that's delivering that service to market. It's a combination of high and unnecessary equipment downtime and your customers expecting you to drive product performance at a higher level. There's the inability to preempt and identify product failure based on past trends as well as existing product performance. And sometimes you get low first-time fix rates and slow resolution times based on not having the visibility to the actual product data. And even worse, sometimes you get wrong product diagnosis and wrong problems identified in part and service procedures, so you're not able to deliver on a first-time fix rate. With the challenges we described earlier around the shortage in terms of skilled workers, we're also seeing a high cost of service driving and impacting the margins that the service business has been challenged to deliver. So sometimes unnecessary dispatches and emergency type of events cause not only you to have shrinking margins, but you have low field service productivity and you don't have the right coverage and the right skills and the right parts at the right time. So the inability to capture and analyze what's going on with the product after it's left your facility and gone to your customer, and the failure to avoid those unnecessary service events are driving shrinkage in your service margins. And with that, you get low service contract renewals. You don't see upgrades and upsell opportunities. You don't get to deliver additional products to those customers that you work so hard to win, and you get a poor service reputation. Smart connected product solutions can help deliver a new way to approach service and address these business challenges. And what we start with our ThingWorx-based technology is a solution around remote monitoring. And remote monitoring provides immediate results both across the enterprise, to the service organization, and most importantly to the customer, transforming your customer success. We've seen significant improvement in terms of equipment uptime. We've seen 15 to 25% reduction in on-site service visits by leveraging IoT-based remote monitoring solutions. And we've seen 5 to 20% improvements on first-time fix rates. All of these driving better product and service outcomes, driving customer success, enabling equipment uptime, and increased customer satisfaction and net promoter scores. And next, I'm going to turn it over to Chris to show you how we do this.
Thank you, Ken. So before I go into the process for building industrial innovation solutions, IoT connected smart solutions, I want to start by saying, and you hear analytics experts like myself or my team say this all the time, but you want to start with the business problem you're trying to solve. Ultimately, I'm going to show you through this slide the process that you go through with our technology, and in many ways best practices for building smart connected solutions, whether they be products or operations. But ultimately, with any solution building, and especially when you're incorporating logic and analytics, which I'll also go through, you want to be able to build a solution that certainly solves the problem, that is answering a question that is well framed, right? Supported by data that you're connecting to and building analysis upon. And then you want to make sure that those answers that you're producing, those insights you're producing, are being brought to the people who can make decisions, or the systems that can take action in a way that is trustworthy and consumable. So always start with the end in mind, right? There's going to be, no matter how great the technology is, right, digital transformation is not easy. The process that you go through from a solution building perspective is not always simple. There's ways to simplify these processes, but if you start with understanding that at the end of the day, the solution that you're building, this web-based HTML dashboard, this augmented reality HoloLens solution, this visualization, right, that is going to be solving these types of problems, if it provides an answer that can be trustworthy and meaningful and consumable, right, well, then that's a solution that pierces through some of this complexity and what's needed to build these solutions. So always keep the end in mind. Best practice for solution building, best practice for analytics, right? So ThingWorx is an industrial innovation platform that follows a process along with capabilities that best enable organizations to unlock value from physical and digital convergence. We start with source, being able to incorporate and aggregate data from anywhere, directly from sensor products and systems, from PLCs to IoT gateways on the factory floor, from existing product clouds, from your 3D design and engineering systems, and from other business systems like CRM, ERP, and PLM. Then you need to be able to contextualize this information. You want to structure the data in a way that makes sense, to organize digital data from your physical systems and products, and enrich it with additional data like 3D geometry, essentially creating a digital twin. Then you need to synthesize that data. You need to gain valuable insight by analyzing, simulating, and predicting physical product and system behaviors and performance, including using included analytics capabilities of ThingWorx Analytics, or operationalizing third-party tools. Then you need to orchestrate or drive action and results in physical and digital systems to automate processes that connect business systems data, products, and physical operations. And last but certainly not least, you want to engage. You want to enable people to perform and make decisions, to clearly present relevant, compelling information on desktop, web, and mobile apps, as well as through cutting-edge augmented reality experiences. Next slide. From that analytics perspective, just like we thought about the business problem we're trying to solve as we built a digital solution from information from our physical products or operations, right? We want to think about analytics in the same light, right? Data is that raw material. Insight is the product. And I think a lot of times when we talk about analytics, there's words like machine learning, artificial intelligence, data science, right? Many times, these are buzzwords, things like big data, right? It's really not about big data, it's about using the right data. And I find it very helpful for data scientists in market, or data scientists at companies, to talk in business terms, to talk about analytics as a broad category of information, not to forget the subtleties and complexities of it, but to understand that at a high level, data is turned into insight via various types of analyses or logic, right? To make the most of data, it has to be transformed into information, which then is transformed into intelligence. So as companies seek to leverage data to improve profitability or boost operational efficiency, analytics makes it possible to gain insights through the application of logic across all business areas. And most often, especially in the IoT space, we're thinking about efficiencies in quality or performance, right? In the service perspective, we're doing predictive maintenance in many cases. Companies want to know not just that their product failed or how to fix it, right? But they want to understand, when is it going to fail? What's going to cause that failure? How can I do something proactive to prevent that failure, right? And yes, that certainly requires a more advanced analysis, right, in the spectrum of diagnostic, predictive, and prescriptive. And most often, the case is that you leverage some type of machine learning, usually a supervised type of machine learning when you have an outcome variable, right? But that still requires that you have, right, a understanding of the business problem. So whether it's a process issue, right, when you're determining when and where to run, or managing setup time, or optimizing an output, or when it comes to assets or products, reducing machine failure, improving performance, increasing uptime, right? These are different categories of problems, right? They may even go into quality, right? Reducing warranty claims, improving yield, right? Or energy, optimizing the product profit, reducing energy costs, determining when or where to run a product to reduce energy use, right? All of these things are specific outcomes. They are categories of problems where machine learning can be applied, right? But machine learning is more than just a cool term, right? And even when you have great automation in the supervised machine learning process of being able to build and operationalize a predictive model, as ThingWorx has within its platform, you still have certain required capabilities for machine learning success. The next slide. And that includes being able to, one, certainly find data, bring it into context, right, connecting to those systems and physical assets that we talked about before in the industrial innovation process. But once I have that data at my disposal, I need to prepare it, right? I need to bring it together. I need to be able to bring information together in a way that describes the business problem I'm trying to solve. And I need to make it ready for statistical analysis, regardless of tool, right? Data prep or data wrangling is not called wrangling because it's easy or fun. It's a necessary evil in the process, and anyone who's an analytics practitioner will be honest in telling you that, right? Data just doesn't come to you in a way that's perfect. You're going to need to be able to ingest that data, to normalize it, to create that training data set. So before you use machine learning automation, you need to create a singular flat file, right? Oftentimes you want to partner or collaborate with someone who understands the actual problem that's being described in that data. What does it really mean to ask a question of a machine that's failing? What does it mean to be able to have an instinct of what's going on, right? And that might take additional exploration, right, before you even model or build a machine learning model for that, right? Ultimately, once you've done this, you have an analytic model representative of the data that you've created for that business problem, right? You need to operationalize it. You need to take new data within your IoT platform to score against it to get a calculation that can be scored in operation. So let's think about this from the service perspective. When you're optimizing service, right, we kind of simplified in terms of, yes, you need to monitor these issues. You need to store that data to be able to get a historic view, right? And you need to predict service and maintenance issues. But people often tire of hearing data scientists say, what's the business problem you're trying to solve? I think I've already said it 3 or 4 times already, right? But it's really what you should do before you try to answer a question, right? Whether it's questions that are affecting you now or down the road, right? Because ultimately, this will guide you on what to connect to, how to store the data in order to create an accurate historic view of data mapped to outcomes or failure modes, which is necessary to take advantage of more advanced analysis. In other words, when thinking about how to use analytics to find a solution to an existing problem or build something new, it starts with framing the analytic question. This helps determine what data is needed to describe the circumstances that may impact or affect the answer to the question. In the big data era, right, companies realized that collecting all data doesn't necessarily add value on its own. In reality, data on its own is worthless. Data needs to be utilized so that all information isn't amassed for the sake of amassing it. You always ought to build something with the data you collect. If you start thinking about data for a purpose, areas of opportunities become apparent, which is a critical mindset in becoming a data-driven firm. Developing for the IoT, connecting and bringing together disparate sources of information is an analytics exercise. So this is especially important when building smart connected products or optimizing service. New levels of maturity are certainly needed in the age of IoT because of the volume and pace of data, which often goes beyond what humans have the capability to process. Ultimately, you can't manage the world of things using simple, rule-based approaches. Companies must go to the next level, embedding advanced predictive, prescriptive intelligence into the applications you build. Next slide. So how do you start with this framing the analytic question, right? What does it mean to clearly define the business problem, right? So I think it's important for an organization approaching building an IoT solution, no less any analytics solution, to understand what this process looks like, what it means to frame an analytics question. Because any of you who have worked for a corporation or an executive that wants to use the latest innovative disruptive technology probably have come to realize that saying we need to build an AI strategy or we need to build an analytics strategy doesn't really mean anything on its own, right? Analytics, AI, these are means to an end. They are not the end, right? So what does it mean to clearly define a business problem? It means to look at that problem and say, hey, it's different than saying, I want to find out when it's going to fail, right? It's what does failure really look like? What does it mean? Am I tracking failure? Is it a Boolean outcome? Or is there some other indicator of failure that I need to define as an outcome variable? And then you need to ask yourself, what does it mean to predict failure? To ask yourself, when is it going to fail, right? For example, one of my favorite commercials is a Geico commercial where someone asks a genie, hey, I want $1 million. When you say that and you're not careful, what do you get? You could often get exactly what you ask for, right? $1 million. So think about it ahead of time. What does it mean? Do you really want bucks or do you really want $1 million USD, right? These little things matter because analytics is only as good as the information you give it the question that you ask. Next slide. And speaking of that, it's not just about the question. You need to use the right data. You need to understand your data and how it relates to the problem you're trying to solve. Is there human bias in the inputs of this data, right? Who is putting this information in? Is it collected by sensors? Is it human, right? Is it optimized against KPIs that people are being measured on, right? There's lots of different factors. And there's also ways around some of those bias in human inputs or even missing data. But that requires transformation or feature engineering. And that will almost always be needed. So brace yourself, data wrangling is real, and it's going to have to be done. And most importantly, while you're doing it, remember that transformation, if it's against scoring data, needs to be replicable in operation. So keep those transformations in mind for codification later. Next slide. And how do you know if your data is ready? A lot of customers ask my team this. They have a connected product that they want to predict failure on. They say they have lots of historical data, right? You'll get the question, is it enough, right? Or what does that mean? And there's no hard and fast rules. There's guiding principles, right? Better data equals better results. Notice how it doesn't say more data. It's really about better data. And what does better data mean, right? Data scientists tend to ask themselves 4 questions or 4 categories of questions to answer this, right? Is it relevant, right? Is it potentially relevant to the outcome variable or thing that I'm trying to predict? Is it internally consistent? Is it connected, right? Are there no gaps in the data, right? The more missing data, the harder it is to provide meaningful insights. Is it accurate? Are there tight groupings of data, more precise data? Because imprecision can be accurate if it's representative of the problem. But if it's imprecision, that's outside of the problem, it's going to be an inaccurate understanding of that problem through the data. And is it enough? More data potentially means more detailed, precise decisions, again, if it's relevant, connected, and accurate. And ultimately, with all this being said, as you build analytics into your smart connected product decisions and applications, or your smart connected operations applications and solutions, remember that advanced analytics, data science, big data, whatever you want to call it, or whatever the latest buzzword is most effective when it is human-centric, right? A human always has to be accountable, right, for the advanced analytics within any solution. You need to understand that accountability. You need to spend time framing the question ahead of time, understanding the data that relates to it. You want to make sure that the analysis, whether it's automated or not, is not black box, that people understand and can trust what's going on, that they can see and understand how the machine learning is affecting the answers to these questions. And you need to look at business success, not simply the data science, not simply the buzzwords, right? And elements in building these, right? So data, domain expertise, data science, data engineering. You need to figure out the logical techniques. You need to improve software engineering skill sets and user design experience, and embed that into the process and applications that we're building. With that, I'll hand it back over to Ken, which I think we're closing out.
Yeah, at this point, I think we're open to take some questions, and then we'll talk about next steps.
Great. Thanks so much, Ken and Chris. We've got a number of questions from our audience, and one of the first one is how, given the integration that's needed to drive this kind of IIoT solution, how does PTC solution work with established legacy systems that may have been in place long before the IoT era began, as it were?
So I think, and this is Chris answering before I hand it over to Ken, I think absolutely you should be. Those legacy systems, or even really enterprise business systems, are often very, very valuable. It's not just about the sensors, right? Whether it's a PLM system, an ERP system. When we say source, we mean sourcing from those systems as well as the physical world. And oftentimes from an analytics perspective, those legacy systems or source systems have the outcome variable in them, right? The failure or success is often tracked in those business systems. So bringing that together with physical data is often very, very critical. So certainly from a technology perspective, our platform, whether it's APIs or other types of modes, can be able to connect to those systems to add context just like we would from physical sensors or devices on the factory floor.
Yeah, and this is Ken. Excuse me. What I'd like to add is the entire solution suite that we bring to the table here is really designed around wrapping and extending your existing data. What we do is we provide solutions, and as Chris touched on, a combination of sourcing data from disparate existing sources and then putting it in context both for the advanced analytics and AI type of use cases, as well as just providing advanced data visualization to allow humans to make intelligent decisions based on that visualization. That is core to our IIoT solutions. So we definitely integrate with existing legacy systems. We actually prefer that those systems of record remain in place because you're driving your business best practices leveraging them. And we layer ThingWorx and Vuforia and other PTC solutions on top of those legacy systems to deliver the IoT value.
Thanks. Ken, I have a question for you. Amongst all the different functions that are participating potentially in an IoT or IIoT project, the plant floor and real-time systems, the enterprise business systems, the design or product lifecycle management, have you noticed any kind of a trend or pattern as to where projects tend to originate and who tends to get the primary or initial benefit from them?
Sure. Today we touched on some key values that impact the service organization. So I'd say a lot of times the initial solutions you develop around remote monitoring and product and service innovation will connect into your existing field service or service management solution, your CRM certainly. So you want to visualize the products and the connected products in the context of the different customers that are using your fleet of products. More on the manufacturing side, I'd say we traditionally integrate with and pull data from legacy systems, both the manufacturing execution system, maybe your traditional automation systems within the factory floor, certainly your ERP in terms of looking at the latest orders, et cetera. So I'd say those are probably the primary systems that we integrate with, and then we provide the existing product telemetry data in conjunction with those existing systems. And I think Chris can add more color.
Yeah, and I think within those two worlds, smart connected products and smart connected operations, right? I think previously or historically in this sort of this age of IoT, especially early on, it started with the most kind of the most expensive, largest, most critical machine in many cases. So you think turbines and assets that are critical to a certain process or customer, expensive assets. That was where the investment and even experimentation had the most kind of return on business value. I think now that IoT has become much more pervasive in market, it's certainly extending to all types of products and in line with the transformation of service goals and customers expecting not just a product that can be maintained, but outcomes along with that product. I think the maturity of the space has certainly increased into all types of products now.
Good, Chris, thank you. Chris, another question for you. We've certainly talked a lot about data quality already in the webcast, but we're continuing to get questions from the audience. And I'll combine two questions into one. Is there a way, if the suitability of the data within a given site isn't adequate, that they can establish a model like using similarity data, as our questioner puts it, to kind of formulate a set of data that could be expected, and talk a little bit more about how things works with the quality of data to make it better.
So I would say it's twofold. One is, keep in mind that I always say start now with what you have, right? It's never going to be the data that you have today can always be improved, right? But you shouldn't just sit and wait for that. You should learn from the analytics or advanced analytics modeling experience, both organizationally on what it takes, but also how to improve that advanced analytics model through the collection of new, better data that's more relevant and connected. So certainly the idea of using similar data or subsets of data to create a sort of a richer, hopefully more accurate view is a good place to start. But there's also a difference between training a model and then putting that model into production. I think that you want to, when you're doing that exercises in the beginning, the experimentation, keep in mind that iteration is important, right? So you want to have a model, and then through the power of automated machine learning and what's possible inside of ThingWorx Analytics, right, creating a ensemble predictive model, choosing the right algorithms that make up that predictive model is an exercise that takes seconds or minutes, right? So, and all of the accuracy and understanding of that data and the problem, right, is automatically fed to you in output. So you might not have a model that's suitable for production, but you can certainly experiment and iterate. So remember that as you get the right data coming in, as you add that or append your data set that you're training that model, right, you can use that to build and iterate or tune those models until you have a model that, depending on the business problem, is suitable for production. A good example is sometimes a 60% accuracy, right, for what you're actually getting in terms of information is suitable, right? If previously, if someone picking out the right color marble out of 1,000 marbles, right, the percentage there, 60% is way better than doing that. It just depends on the business problem. But I would say at the very least, even if you do need precision and a higher level of accuracy, start with what you have. Know that as you get better data and more relevant or accurate data, you can always tune that model until you have something that's suitable for production. Hope that answers
So
your
then,
question.
Chris,
Yeah.
as you go along, even the goals of the project may change as you start to get better answers and understand what parameters are most important?
Absolutely.
Great. Ken, question for you. In your examples and your case uses, there were a number of different industries represented, but are there any industries in particular where you see the most interest and dedication when it comes to the industrial Internet of Things and analytics?
Certainly. I'd say traditionally, some of the initial, I'd say, products that became smart and connected really started in medical device. There was machine-to-machine connectivity because those pieces of equipment were landing within hospitals or medical facilities that had connectivity established and outbound connectivity into the internet. But more and more we're seeing industrial products and in certain industries, depending on how those products get installed, whether they're in a field setting or whether they're in a factory setting, the connectivity is getting much more pervasive. So I'd say first medical device, then electronics and high tech, and now more often than not, industrial companies are really differentiating their products. The example I had up front was actually based on PTC's first customer, which was John Deere. And John Deere, as an example, has had their tractors smart and connected and had the ability to deliver over-the-air updates and change the configurations of their equipment for years now. So it's really just a question of when an industrial product becomes smart and connected and how it interacts with an overall product system. More and more software is getting applied to to the metal and plastic and other pieces that go into that equipment. And frankly, the product configuration is getting more and more complex to deliver, customized business value for those end customers.
Well, thanks, Ken. Chris, a question for you, and perhaps you'd like to chime in afterwards, Ken. One of the most fascinating things about these types of projects and engagements is, again, the way they span the real-time automation realm with the enterprise itself and information technologies from the business systems. But, one of the biggest human relations related items that are discussed in these circles is, how do operations technology people get along and how do information technology people get along? And there's been a lot of ink spilled on that and a lot of things said at conferences. Now we kind of have a new one emerging where you have how do data scientists and domain experts work together?
Yeah.
Ken, given your experience in the Center of Excellence, how do you see those kinds of working relationships evolving? On the one hand, IT and OT, on the other, data scientists and domain experts.
Yeah, so I think it's a great question, and frankly, I think, and it's odd that someone who makes a living at a software or technology company is one to say this, but I think the technology and software is frankly there, that the limitations are not within that realm. It's really within an organization's ability to create motivation and a reason for the right people working together. So just like physical and digital are converging, like we say, I think IT and OT are converging. Now, how they're converging is where the rubber meets the road, so to speak. Right, so I think it's not even an issue of connecting sort of these OT systems with IT systems, right? I think that world and remnants from it, that legacy world of buying decisions from the the plant manager versus the people in IT, still exists. But I think the difference between someone who's really successful in a digital transformation journey versus someone is not is how those people work together, right? Just like IT and OT, a true partnership and collaboration. How does information from this one factory, right, affect a process that goes across multiple factories, or how does the performance of the enterprise made up of multiple factories work together? Well, that requires a collaboration, not just in terms of the technologies and the data, right? It requires a personnel collaboration, right? And from an analytics perspective, the most successful customers we have with advanced analytics, not just being able to create a model, right, but actually use it, trust it, consume it, have a meaningful impact on the business, is often the heart of that is a domain expert working with, a data scientist, or even if you don't have data scientists, someone who is analytically savvy, someone who knows about the data, knows how to explore it, right? There's automation technologies that don't necessarily require, the PhD in data scientists, although they're always helpful, right? But that collaboration between someone knows how to ask a question of a product or an operation, working with someone who knows how to bring together data to model it algorithmically, right, is so critical. So I think that we still have a long way to go, right? But the companies that somehow find a way to incentivize that behavior and that collaboration between IT and OT, between domain experts and data scientists, are the ones that are successful, and the return on that investment, even regardless of technology, is so massive that I think that I'm seeing it much more even in the past few years than I have in the past 5 to 10 years. So I think it is very, very promising what's happening in terms of cultural transformation within organizations pursuing these strategies.
Thanks, Chris. Chris, I've got another question for you from our audience, and they're asking, it's actually a well-known research analyst, and he's asking, how are you guys working together with Rockwell since the investment?
Mm-hmm. So I think it's a perfect tie-in to, that IT and OT convergence, right? We are PTC's expertise, certainly we've been working in the space, but we're a software company. Rockwell has been part of that OT landscape, both with hardware and software, and certainly that domain expertise on the manufacturing, on the automation side that Rockwell brings to the table. We are working together incredibly well. So I think companies often, talk about partnerships or chime in on them, but when we say strategic partnerships, both with Rockwell and with Microsoft, we're not a company that has a million strategic partnerships. We have primary, we call the big three, right, with Ansys, Microsoft, and Rockwell. And these are partnerships that we live and breathe and work on and iterate on, both Ken and I, all the time. And, both of us are involved in all of them in some capacity. So Rockwell, it's really taking off. I think just from a technology perspective, they have analytics capabilities that help with some of the stuff that I was talking about, being able to understand and normalize data, especially data that comes from those OT or automation systems at the control layer, right? We provide sort of the automated machine learning capability to sort of simplify and democratize some of that machine learning. But across that paradigm of what it takes to prepare, explore, and operationalize machine learning models together, it's a really powerful portfolio of technologies, just like Microsoft helps us in many ways in terms of storing data, working with their analytics capabilities, right? It's partnerships that are intentionally built and chosen by our respective companies to really unlock digital transformation at our companies. I'll let Ken build on that. Or no.
Thanks, Chris. Ken, the final question of the day is for you, and I'll just simply paraphrase one of our listeners' questions. And do you have any thoughts on what the best way to educate people on how to recognize business problems within data and realize that there's answers that can be gotten out from that data?
Sure. I think the way we approach our engagement with most customers, and we want to be that trusted technology partner, is to do an assessment, understand what are your business objectives at a highest level, as Chris touched on. Okay, what are you trying to solve? And then review, where and what type of data you have in your legacy systems. And we usually do that through some type of, workshop or event. And we have clear return on investment calculators that we usually apply to that. So we look at, what are the different data sources? How can we apply some of our PTC technology to, either source the smart connected product data or connect to the OT systems, whatever that is, and then frame up what that end result is going to look like. But it's all based on defining that clear business problem up front, which is what Chris touched on as part of defining those analytic models. It's about having the right data and the right data sets and contextualizing it. It's not around just having a big data solution where we pump all this data into the cloud.
Well, thanks, Ken. That's all the questions we have time for today. But we'd like to thank you for joining us. We'd like to thank our speakers, Ken Rawlings and Chris McDonald, for sharing their time and expertise. I'd also like to thank PTC for sponsoring today's webinar. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as this webinar concludes. Please take a moment to complete it as we use this information to improve our webcast. On behalf of CFE Media and Technology, thanks for attending today's webinar, and we look forward to seeing you next time.